So first, I'd like to start by telling you a little bit about Firia Labs. We are a Madison-based company, an EdTech company in Alabama, and we are comprised of engineers and educators who are focused on physical computing, particularly the curriculum, software, hardware, and tools that are needed to teach Python programming, text-based programming to students. And our goal is to demystify technology so that people can be creators and not just consumers of it. As we move forward in society, so much of what we do is technology based, and we believe that everyone should have the right to contribute to the conversation of how technology gets created, not just be forced to take whatever technology hands us. Okay, so next up, what is physical computing? Physical computing is the process of working with an external device. So beyond using the computer, do we have a piece of technology, say like a microbit, that's what I have today for this demonstration, that we are using to interface our code with that particular object. And so the thing I love about physical computing is that it's an embodied experience for a student. It's not just putting words onto the screen and seeing what happens on a screen. There's actually something that they can touch and sense and feel that they are actually controlling through the use of their code. And so it creates a stronger connection between what they're typing and the actions that the device is actually taking. Python, in particular, we chose this language because it's a popular general purpose programming language. We also chose it because it has multidisciplinary applications. Python is something that is used in data science. It's used by engineers. It's beginner friendly. And the syntax is a little bit easier than some historic languages such as C++. And it's more structured than something like BASIC. And more than that, Python is a marketable skill. And so we like the idea of students a teacher being able to tell his or her students that the thing you're learning right now, like if you chose to study this in depth and get good at it, it's something that you could get a job doing. In terms of what shapes our use of Python and the projects that we offer, our engineers at Firia Labs are Internet of Things engineers. And so the applications and the projects that the engineers at Firia Labs work on, their experience has been from things like alternative energy, applications in construction, food service, utilities, making sure that things are energy efficient. In the case of construction, making sure that workers are safe. So if, say, the chemical components of the air change and it becomes unsafe, IoT devices can tell a construction worker that they need to get out of that building, or it can alert a foreman that they need to go and see about a worker if they're injured. Same thing with lights. Internet of Things is around us every day. I love, with the microbit in particular, that this is the same little piece of tech that's in the restaurant buzzer that they give you to tell you that your table's ready. Although we're not doing as much of that thanks to the pandemic, but it's all around us. And in our curriculum, we do project-based learning. So everything is a meaningful task in the sense that we're not just asking you, hey, go program this thing on a microbit or program the CodeBot to do this. It's all inside of a context. So some of the projects here, these graphics, we have a nightlight. There is a photo cell that comes in the Jumpstart to Python kit that allows students to program a nightlight so it actually pays attention to how much light is in the room. We have things like a spirit level where they can actually use the LED display of the microbit to determine whether or not the microbit is on a level surface. My personal favorite of the projects was the one where I got to use the radio frequencies between two microbits and to communicate the temperature inside the refrigerator from a different room. And so I could use the thermistor to see how cold it was inside the refrigerator. You could also use the photocell to see if the lights really go out in the fridge. There are also music applications, as well as things around security as well. The way in which we deliver this particular piece of software is through a web-based browser. And this tool is called CodeSpace. And the development of CodeSpace was funded in part by a grant from an SBIR grant from the National Science Foundation. And we developed this tool that allows the curriculum to be fully integrated with the coding environment. And so the coding environment is a full development environment. You can do anything you want to in that particular environment. So although the projects are narrow enough for a student to interact with them, hi Jeff and Rosa and Tracy and Matthew. I was just like, wait a minute, there are people over here. So the tools that we have in I've been in there all by myself, so I just thought, I was like, well, let me do a good recording. The tool that we have it's web-based. It works on any Chromebook. It's delivered through a browser. And David Ewing, the one who created this tool, one of the things, okay, thank you, Jeff. One of the things that was behind the design of this was that he was a small kid growing up in Georgia, and he was into electronics and didn't really have a friend to talk to about it, or an older adult to say, hey, here's some things you can do with coding. And so there's an avatar in here, and he's designed to be a guide on the side, as well as to alleviate a teacher of the full need to understand Python completely to deliver it to a student. So it's really designed that a student can work independently if they have a high interest. And there's a debugger, which is one of the things that at the time that we built this was missing from the market. And the error messages have been changed, so they're not the straight compiler messages that you usually get when you're in a development environment. There's a little bit more context given so that you can understand what's going on. So let me go on to the next one here. So we're here to talk about productive persistence. Show of hands of the few that I have here. How many of you have students that give up on the first try? Tracy's like, yes. Oh no, not almost all of them, Jeff. That's tragic. Hopefully I will share some things in the next few minutes that can help you get them over that hurdle. My background is in mathematics, and so I suffer from long-term exposure to mathematics, and I've also taught computer programming as well. Yes, Jeff, that is so true about high-achieving students. They're not always used to struggling. All of those things. And so it's good for all students to be able to get better at productive persistence. But, all of the math story to say, I know what it looks like to struggle with that, both teaching mathematics as well as teaching computer programming. So productive persistence is this cyclical event of testing the code that I wrote, seeing if it's doing what I want it to do, inspecting what I did, and then adjusting the process, changing the code that doesn't work, and then starting all over again. However, if a student gives up on the first try, we're not even going to get on this circle, much less actually complete a task. And so one of the things that's nice about a debugger, and particularly in coding, like with coding, the thing I love about it is that something's wrong from the very beginning. And coding allows you to write your solutions in small chunks. As a math major, especially in grad school, there would be times when I'd be working on a proof and I'd be 3-4 pages into this proof, and then I'd get to a calculation that said 1 = 0, and I'd be like, oh, that's not true. Something's afoot. And so I erase a little bit and I go back up and I erase a little bit more and I go back up and I go back up. And then all of a sudden I'm on the first page. And it's devastating because I've been working on this proof for hours. And now I realize that the first 3 pages of it are complete junk because I made an error on the third line of the first page. Coding and a debugger and knowing how to use it allows me to code in smaller pieces. And if I want to write big chunks, it can point me to where my mistakes are. So if we're good at this whole productive persistence thing, we're going to be building some computational thinking and decomposing, breaking problems down into smaller pieces, pattern matching, abstraction, being able to pull out something from one context and use it in a different context, especially like with making functions. Coding is wonderful for that. And then just checking your algorithms and being able to create consistent ones. All of these things are great when we are trying to build productive persistence. We need to have that in order to meaningfully engage in these 4 particular aspects of computational thinking. So I'm going to, without further ado, hop on over here to the, I'm going to have to resize this. I couldn't see myself when I shared my slides, and that was problematic. So this is CodeSpace. And CodeSpace has several features, one of which is a teacher dashboard. I'll just give you a quick preview. So you can actually see who's in your class. You can monitor what's going on with your students, depending on which project or product they have. You can see what those things are, and students can join your class. This is connected to Google Classrooms, so you can actually integrate all of this into a Google Classroom if you like. Let's go ahead and talk about what it looks like to debug. So how many, show of hands or virtual hands, who's done Python in here before? Tell me about the room I'm in, because I don't want to torture you unnecessarily. Have you taught before? Are you a CS background person? Okay. So Jeff has not, but it's going to follow. No Python, only Java. Okay. Ooh, Pascal. Hey, Matthew. Man after my own heart. I had Pascal as an undergrad. I was one of the ones in the main session talking about that TI 499A that my parents had. Okay, and Rosa is teaching Python. So I'll go ahead and come from a more novice approach, which is a lot like the student's approach. So first off, I've got to connect my microbit and make sure all of that is working. Yay. And then there's no yay. Why are you not yaying? This is no bueno. I am not sure what's going on. I just tested this and then I broke my code so that I would have something that we could debug. And now I'm not connected. Give me a second. I had a mentor that used to say no one should take derivatives in public after 40. Okay, let me grab a different microbit as well as I will be right back. All right. No. Well then, this is the saddest of sads. Ah, okay. There are lights on, so that's promising. But I am not connecting. So we are going to do something different. And I am officially off script. But we're gonna do something different. Let me stop sharing for a second while I get this together. Okay, here we go. I apologize for the delay. All right, so we are going to use the CodeSpace simulation environment since I am having a not smart enough moment with CodeSpace. And I'm not sure if it's my adapter or if there's something else I'm doing incorrectly. So the simulator typically is designed to mimic our CodeBot product. And usually that's the physical device. This is the virtual representation of it. And you can see what it looks like. It's a circuit board. It's a real thing. And there is a surface that it runs on. This is free to try. So if you want to follow along with me, you can actually go and enter the simulator yourself. So you can go to sim.firialabs.com. I'll put it in the chat. And so with the simulator, there are missions that are just like Jumpstart to Python. And here we have the motors. It tells us about the motors. And we can see that. And it says complete the current objective. So let's see. I have gone through the welcome. So now I am introducing the CodeBot. I've gotten to know the way. Let's see. You guys are going to get to see me make mistakes in real time. So it's computer on wheels. We've got line sensors, LED lights. So I'm going to say continue. And then I want to locate the motors. Yes, I see where they are. Oh my guy run? Oh, he does. He just kind of runs in circles. And so here I have a debugger that I can look at as well. Let's see if we can do the LED lights. At this point, I'm going to stop and confess that I'm almost at 5 months with Firia Labs. The products are still new to me, and I'm having a moment that I could not recover from. And I want to give people a chance to ask questions if they want to ask questions, and see if I can be of some value in this session, because I did not practice with doing the simulator, and I haven't spent as much time in the simulator as I have with the microbits. And so I am, I don't know how to correct what's going on, and I'm the only one from my team in here today. So Tracy and Matthew, you're still here. Do you have questions? Things you want to know? I realize that I have not it's been a not okay day. Thanks, Tracy. I'm just like, I'm trying to save myself. It's not happening. Okay, so Matthew, the kind of licensing structure that we offer, it is a perpetual license. The simulator is in beta. It is actually not available and ready to go into full classroom use. However, the way it works, that I can actually show you if I share my screen, because you can see that from the teacher dashboard. So when you join a class, if you go to the curriculum, there are seats available out of the number of licensed seats. So the licenses are per individual, but not per student. So we recommend that if your largest class is 30, then you need at least 30 licenses, because that's how many seats you would need. And then from there, you can reuse those licenses every class period, as well as every school year. As far as how you get the seats to your students, there's this share token. And it's a 2-word code that you give to your students. And you can change it when you manage licenses. I could go in here and I could generate a different share token if I wanted to, and then I would give that to my students. But usually people keep the same one. You don't have to change it unless you need to say boot students out. What else? Okay, so that depends on which product you're using. So if you are using our Jumpstart to Python, let me just go to the Firia Labs site right quick. So if you're looking at the Jumpstart to Python, that is based on microbits, and this is what we consider our gentle journey into Python. All of our products are designed so that someone without a STEM background can actually use them in their classroom. But if you've never done any programming whatsoever, we recommend you start with the Jumpstart Kit or using the microbit curriculum, because it explains, it goes into more detail as it brings you into learning Python. If you are looking at the CodeBot, which is the robot that we have, that one is geared more for high school. And so we usually recommend Jumpstart to Python for upper elementary. We've seen it in like gifted classrooms with fourth graders, middle schoolers, and then the high schoolers tend to use the robots, or students that have done other programming will use the robots as well. What else? Other questions? You're welcome, Matthew. There are other resources. Go ahead and share that so you can see those. And those teacher resources, they are TEKS aligned and CSTA aligned as well. You're welcome, Tracy. And those are also on our website at the educator resources. So they're all here. Standards for every state, there's student resources, there's a pacing guide. And there are pacing guides aligned to AP, CSP, as well as CS discoveries and such. And there's some cross-curricular alignment with the Jumpstart to Python labs. I see y'all are still with me. Do you want me to open up some of these so you can see what they look like? So if you were going to use Jumpstart as an elective, it's lined out by week with a display or description of what each project contains. And so this pacing guide is for an 8-week class. If you would like to get in touch with me, I am Rhoda at firialabs.com. And if you want to follow me on Twitter, I am at FiriaLabsLife. You can also follow us at Firia Labs as well. Thank you for your time, and I appreciate you being here.